All right, welcome back. We're looking at using the subplot command today as an option for graphics. So we've talked about the concept of being able to use figure diagrams. I did want to talk about a concept that I saw last time. So I think we did a graphics sandbox. Go ahead and just resave and overwrite. Okay. So here we do figure 1. Okay. And then I think we've talked about the idea that I could actually plot. So let's do this. Let's say that x is, I don't know, 0 to 10. And then y is the square root of x. And then we'll go ahead and plot x versus y. And we've already talked about the different things going on in the background there. There we go. How would I get, this thing is kind of linearly interpolated, how would I make it more smooth? Yeah, so I just take this thing and let me go ahead and dock that. Put a smaller discretization is what I would call that. So now I run this thing again, much more smooth. And we have the concept that we could actually change the figure window. So now I have figure 2. And in fact, because I haven't actually non-stored figure 1, so this is now, remember that this is a variable in Matlab. I haven't actually updated that variable at all, so I actually have now 2 figure windows. And one of the natural questions that we might ask ourselves is, well, what happens if I wanted to actually have these 2 figure windows in the same, these 2 graphs in the same figure window? And that's what subplot is designed to do. So I would be remiss if I said, let me teach you this. Best way to figure this out is to read. So here we have this command. It creates axes in tiled positions in a single figure. And then it has very, very specific syntax. So what is M and N? What comes first in MATLAB? What does MATLAB stand for again? The word MATLAB? Matrix Laboratory. And one of the things that's really nice about MATLAB is it's an array-based language. In other words, it stores all numeric variables as matrices. Anytime I have a matrix, what index comes first, the rows or the columns? Rows. So could you guess what M is? Row. What is N? Columns. And then the question is, well, what is P? So let's go ahead and try this. Yeah. So here what we're going to do is we're going to say, let's give our subplot, let's create a 2 by 2, and we'll start in the first position. Okay. So now this is a handle to that position, and then what I can do is I can tell the plot command, hey, I want you to plot x versus y in position 2 of that subplot. And in fact, what we'll do is we'll actually fill out all 4 of them, sorry. Okay, so why am I saying that there are 4 positions? Yeah. So in this case, we'll call this position 1, position 2, position 3, position 4. And it's not very interesting because we have the same kind of fun, right? Okay. What if we wanted to control, So here's an immediate question that I have. What if I wanted to graph, I don't know, right here, what if I wanted to graph sine in this position? What would I do if in this position? So did you see that? Sorry, I should do that code a little bit slower for you. Okay, so let's do a little bit easier example because I think I just saw some eyes roll over. And then maybe we should follow the Matlab documentation a little bit more slowly. So one of the really cool things about Matlab, do you see it? So if I want to know how subplot works, I can literally just take this code and copy it there. Right now I'm in my sandbox, so I don't have to actually comment much, right?
It's not saved yet, it's okay.
We'll talk about, yeah. And kind of an interesting feature of this is I could, if I wanted to, use different axes in both of these, right? So there's no reason why I have to use the same axes. Oh, of course it's going to get mad at me. This should say x2. So do you see how those two axes are non-linked? So let's kind of run through this code together. What does that first line do? I create a figure object that has a ton of different properties. If I wanted to know what properties those were, I could literally just run the get command. So get fig1. Those are all the properties. It's time for me to clear. Oh yeah, what did we learn about this? Was kind of interesting, wasn't it? I don't know the answer to that question. So if I run this thing, right? And then I write get fig1 in the command window, yeah, it does work, okay. Okay, so that first line of code literally creates a variable with all of those different properties that I can control using the dot notation, right? And then what does this do right here? Yeah.
What did you add tabs?
Say it again.
Why did you add tabs?
Why did I add
Tabs, the sort line, fourth line.
fourth line? This one?
Yeah, like the tabs before you have spaces before.
I think it's I copy and paste it. I'm not sure, to be honest with you. Yeah. So this is called indentation. So I know that you're asking me why I did that as a coder. Everything that I do down here, I'm doing to fill figure 1, right? So I like to think about figure 1 as kind of the parent line of code, and then everything that I do under that parent, I want to say like it's distinct from the other code that I'll run. So let's say that down here I did a new figure. So as a coder now, if I wanted to find my figure 1 content, I can immediately go to that, right? And this is where you could use your really, really nice, you all know that double parentheses?
So it's more style?
It's style, it's for legibility. So, and then I think, I always forget how to do this, because I run preferences. There we go. Okay. Auto formatting. code folding. There we go. And I want to code fold by sections. Let's try that. Yeah, you see it? So let me show you what I just did there. I went home. I went to the Home tab. I went to Environment, and I went to Preferences. We spent about 10 minutes looking through this the first day of class. There are times as a coder where I want to do a ton of work in the same space that I'm doing other work. But I don't really want to look at all that work. So Matlab has this really interesting thing. If I put a double percent sign, percent, that creates what we call a section. And in fact, so here is, and I probably would do it in all caps, here is section 1. Now I can, or even you could just call it section 1, right? Section. Section 2. Right? If when I have this thing, if I actually go by sections, there it is. So I need a little space in between. Now what ends up happening is when I'm doing my coding, I can focus on the blocks of codes that are most interesting to me, and I don't have to read the 75 lines of code in between, right? So once again, the way that I did that is I went to Environment, Preferences, Code Folding, and then I clicked on Sections because that was off previously. And then what's nice about this is MATLAB allows me to say, yeah, please have my sections folded initially or don't have them folded initially. And there's kind of all these other different things, like they allow you to do this for loops, classes, function codes. Those are beyond the context of this introductory course. But again, if you're interested, learn how to do that. So what's really nice about that then is when I indented it that way, I now know like all of this code is dedicated for that section, right? So what I might do actually up here before we have section 1 for figure 1, I might actually create a few different y values. So the first one we'll do is sine. The second one we'll do maybe is cosine. The third one that we'll do is the square root function. Fourth one that we'll do is the exponent, and I believe in MATLAB the exponent is exp. Okay. So right now I could graph 4 different graphs in one, right? One way to do this there we go, editor. Is to actually just have each graph in its own figure, but the whole point of subplot is it allows me to have multiple graphs in the same figure. The normal way that MATLAB tells us through documentation to use the subplot command is to run it like this. Like first tell myself I'm going to use this subplot, then fill it out, then do the next one. Yeah, and then this is what I was used to way back when. This is how I used to do all titles. So this title command allows you to control titles. This is bringing me back to the old days. Do you see that? Like you can individually title each of your subplots. So I'll let you read that documentation on your own. What I do want to share with you is something that I haven't seen done in MATLAB's documentation, but is kind of useful. In the same way that we use handles to talk about figures, we can also use handles to talk about subplots. So here, this subplot command basically partitions my figure into how many rows and how many columns. 2 rows and 1 column, and then it says like I want to position this specific subplot in position 1. So my question is, well, what is position 1? what does that actually mean? But what's really nice about this is then I can say, hey, right here, please plot in position 1 this thing. And what's interesting about that is, and this is what I was trying to do when we started with this, I can now refer to different positions like this, right? So if I define my individual subplot positions, let's parse that line of code. So what is this saying right here? Let's look these first 2 lines of code. What is this saying? Yeah, I want to let H1 be the handle for that position, and I'm going to let H2 be the handle for this position, and then I'm going to tell Matlab, hey, plot in H1 a comparison between X1 and Y1. Plot in H2 a comparison between X2 and Y2. One question that I have is what would happen if I do this? So what's going on there? Kind of an interesting plot here, right? Those are different plots. This thing right here, what is it? Yeah, we should really, one thing that we could do is make this a little bit better, right? Let's change this from 0 to 0.1 to 2 times pi. Why is Matlab? Oh, I see why it's getting mad at me. Because I'm not using this thing. Let's turn this thing off. Okay. Does somebody see what's going on here?
I think you have to clear your workspace.
Oh.
It's storing an old figure.
Okay. Okay, so the question is, well, what is this thing, right? And how are we doing this? I didn't specifically tell Matlab what to fill in the other positions, right? So maybe one of the things we can do is start to figure out, well, what do the different positions mean? So from that standpoint, let's just go ahead and start playing with that. Let's call that Y3 and Y4. Call that H3 and H4. Okay. So let's see if we can count the positions. Which position is which? So the first one is sine. That's in position 1. Position 2, the claim is that it is in What does position 2 get? Yeah, H2 is position 2, and it gets the comparison between X and Y2, which would be what? Cosine. Okay, so question, does MATLAB label its positions 1, 2, 3, 4, or 1, 2, 3, 4? The first one, right? It goes 1, 2, 3, 4. One of the questions that I don't actually have a good answer to at this exact moment is, what happens, what if I wanted to have this single graph right here, this one, span these two positions?
Oh, just put it inside the matrix. Say 1, 2, space 1, space 2. You can go space 1, space 4, and just be dots.
So you're telling me that if I did this one, if I did,
Yeah, in brackets.
let's see, did we break it? Nice.
I was just doing that myself.
That's kind of fun, isn't it? Okay, so I don't know whether or not it's the case. What I had thought about is, if these are handles, you would imagine they have properties, right? So if I do get H1, so check this out. What's that tell me now? Okay, let's go back to this line of code. Yeah. Okay, so here we go. So let's think through what this is saying. So what is this line of code saying? Figure equals fig1. What does that say? Create a data class that's called figure that basically opens a window, right? This thing right here, what does it say? This is a handle. H1 is going to be a handle to a child of figure, right? Called a subplot. So what MATLAB is going to do in that situation is take this original window and cut it into pieces. How many pieces is it going to cut it into? Four. 2 rows and 2 columns. And what's really interesting about that is each piece, so now implicit behind MATLAB, this is piece 1, this is piece 2, this is piece 3, this is piece 4. Each piece is going to have its own, what do you call these? Properties? So check this out. What is the child of H1? What is H1 filled with? What is the piece? So here we took this figure, we cut it into 4 pieces. The first piece over here, we're going to call piece 1, right? What do we fill piece 1 with? What type of object are we filling it with? A line, which comes from plot. So when I hit this command, when I do this right there, basically what it says is, hey, take that place that I called H1, fill it with the comparison. That thing is now what we call a line object, right? When we go back here to the properties list, what's the parent of H1? What type of object controls H1? Figure. So the hierarchical structure that happens in this particular figure looks something like this, right? We've got this thing called root. What is most for this is figure hierarchies. What are human beings called root? the display or the screen on your computer. Underneath root, what did MATLAB create? An object called figure. This is the actual window on which the figure will display. And then in this case, we had something really interesting happening. We actually created these subplots These subplots were not windows of itself, but they were partitions of the original figure window, right? So when we did it 2 by 2 and we individually populated, we literally created space in that figure window, each of which had its own location. And then what we did, so these are subplot 1. Yeah, and what's crazy about this is, in this code, it looked something like this. Fig 1, if I want to access this figure, the properties of it, I use the variable name fig1. If I want to access the properties of subplot 2, I use the variable name h1. If I want to access the properties of the second subplot, variable name h2. And then when I run the plot command, so when I go back and I run this thing, what does this do? It says in H1, in that position that I'm in H1, please graph this, but it creates, that's called a line object. And I'm guessing the reason that the MATLAB people call it a line object is because the primitive on that is lines. You see it?
Objects built into each other. So that's another reason why it might be called line object. Object-oriented programming states that all interactions within program will use objects within objects.
Objects within objects. So in this situation, each one of these things is being populated by a separate line object, each of which was told, oh yeah, by the way, this is where I want that. So please put that first line object within that subplot, which is within that figure, which will show up on the screen. Put the second line object in the second position that will show up on the screen, and the third one. And then what's really kind of powerful about that subplot command is I can now control using vectorization. I can say to myself, like, actually, I want. So here's a question. What if we wanted to, instead of, so we've just seen Taylor told us how to get one horizontally. So this line of code would get that across. What if I wanted to do it vertically? What if I wanted a vertical thing here and then 2 plots next to each other?
2, 4.
Yeah, so what if I did 1, 3,
Then separated that out.
2, and 4? Okay. Here's a question for you. What if we wanted to link the axes?
Would it work for 1 and 4? I want to see an error message that's like you can only marry graphs.
Yeah, should we break it? I'm down to try it. So I guess this would have to be 2 and 3, right? Yeah, we broke it. Yeah. And we could also, of course, do 1 and 3 and 2 and 4. I mean, we literally could have any. Okay, so one of the things that's kind of interesting here is that every one of these graphs could have a different set of axes, right? So there's no reason why right now we chose this set of axes arbitrarily, but I could actually choose 3 separate or 4 separate axes for my 4 separate ones. So that why don't we go from like negative pi divided by 2, we'll go up by 0.1, and we'll go up to pi divided by 2. And then here, I could actually change this from x1, x2, and x3. And then why don't we do something crazy like, I don't know, like negative 20. We'll go up by 5 and we'll go up to 100. Let's not break the square root. What is it complaining about? Oh, okay, so that's really interesting. What did it just say? It says that I didn't update my my code here. So what do you notice now? Are the axes linked or unlinked? Like this one down here, does it have the same scale as the one right there? Okay. So one thing that we could try is we could say to ourselves, let's go ahead and link the axes on my subplot in the X, and we'll do those in positions 1 and 3. What do you notice? So previously, what did Matlab do? What is position 1? Position 1 stores, this is one of the nice things about having this, right? It stores the sine function, and at base, it's supposed to go from 0 to 2 pi, right? What did position 2 store? Yeah, negative 2 to 2 pi. And then when we didn't link our axes, when we just go ahead and say, let them do whatever it does, Matlab individually chooses what the axis will be. So it kind of fits, maybe I'll clear this. Kind of optimally fits this axis here, and it optimally fits this axis here. None of them are linked. But the moment that I link the axes, Matlab, what it will do is will say, hey, listen, these two graphs should be correlated. Let me try to correlate them. Okay, here's a next question for you. What if I wanted to, so let's go back into here and let's put get h1. So what is this telling me? These are all the properties of that subplot mechanism, right? Let's do this. Let's change h1 dot title equals fun with Matlab. Oh, yeah. Title is a class of axes, must be primitive. So what does that tell me about? I think I can do this. Let's do help GCA. So that one of the things that I wanted to know here is, can you? I don't actually know the answer to this question because I haven't had a chance to actually do this. Can I? This is a handle to that subplot, right? So one of the ways that I can do this is I can use the title command in the appropriate spot to change the title. But what I would love to do is get the handle to that axis to be able to use the dot title and then just individually tell what the title should be for my different axes, right? So, say it again?
Title.
Oh yeah, so I agree with you completely. One way to solve this problem is the way that Matlab does here, right?
Right.
Yeah, so if you're welcome to take a look at that. A question that I have though is, can we get, so modifying axes properties using this creation, right? Yeah, see, so like, that's really frustrating. Say it again?
It's a function, the title, inside the function.
Yeah, I see that. But here's a claim though, right? And it could be they haven't figured this out yet, right? I mean, this is definitely the case that the longer I use Matlab, the more they figure out because they just have more time doing it. But my feeling is that I should be able to set the individual colors and individual titles based on those pieces, right? We can leave that as an open question, but you now have access to subplot and you have enough to finish your lab 4 subplot commands, right? So if you want to know more about how subplot runs, I was hoping I could figure this out with you. If you want to see how I actually run this when I'm doing this, so I now have something that I desire to do, right? I want to be able to control the individual titles of each of these subplots using the dot command, like I did previously. I find that dot command to be really, really elegant, right? Matlab is claiming to me in documentation that the only way that I can control the title is using the title function. So I agree that for starters, that's what I can do, but I want to know, can I use the dot command to do that? So I would go off I would give myself a 15-minute time barrier, and then I go find the answer to that. The last thing that I'll say today before I shut up is the following. Some of you have, when I was speaking to you, shared with me that you've not written code before, which is really exciting. And so I want to share with you what I like to talk about the development process. And to do this, I want to show a little bit of how I would attack this lab. And then I'll shut up for the rest of the today, I promise. So when I think about developing a Matlab code, there are kind of two phases that I like to think about. There's the testing and problem solving phase, and then there's the implementation phase. And then I like to think about modularizing my development. Modularize, cut into pieces. So one of the first things that I would do when writing code in this space is open a file for myself that I literally call sandbox. This sandbox file is going to be where I test code that I think will eventually work. In a separate space, that would be part of my, what I would call testing. So when I'm going to write code, one of the first things I want to know is, can I write code that solves my problem? That's a very, very different thing than writing good code that I implement into a larger project. So when I'm thinking about Lab 4, the first thing that I did, actually, before I ever opened the entire thing, is I started to say, like, okay, well, I'm being asked, there's two separate problems in Lab 4. One of them is to solve the fixed integer class. The other one is the code, the plotting one. So in many situations when I'm asked to write very, very large pieces of code, I like to think about having a master script file that will do all of the coordination between my subclasses. So for C programmers, this would be called your main file. It's the one that kind of like determines everything else under it. And then these will be specialized. In Matlab, we call these function files that go run and do special things. So when I'm thinking about developing a solution to a code, in this case, we're thinking about a plotting function, the first thing that I'm going to do is I'm going to create a script file that kind of runs through all of my details. And to be quite honest with you, when I first create my script file, I don't do it in a highly documented scenario. So this, you remember this thing? This is super well documented, right? That's not where I start my script. So like probably what I would do if I was doing this is I would have what I would call like a test script file. So I would literally create a blank script file that I called test script. I would put it in the proper folder, by the way. So now what I'm, maybe the first thing I do is I get my data. So I import, I think it was CSV read, and I've already given you access to that, whatever that is, and I call that data T. For now, why don't we just do a fake command? So I'm going to call this T equals I of 5 times 5. Okay, so now if I do T, it is indeed that matrix. And then everything that I want to do with T, one of the things that I would say is I start to test out my ideas in some other space. So the sandbox, what the sandbox allows me to do is it allows me to find a solution to my problem without being connected to my original code. And the reason that that's nice is I don't like to think about solving a large coding problem as write a bunch of code, don't test any of my code, and at the end of the day I go, and then I run it. Instead, what I like to think about is every problem that I want to solve, I want to chop into a selection of smaller problems, and each of those smaller problems, I want to have fully functional code that solves the smaller problem that I then port back into my larger solution class, right? And so what ends up happening is the sandbox code that I like to use is my testing scenario. It's where I test all the ideas of how I think I'm going to solve the problem. Once I get a working solution, I delete all the shit code that wasn't useful. I focus in on just the code that solves the problem. I port it back into my script and then make sure that the solution that I've done integrates into the larger coding structure that I'm using to run my entire situation, right? So what ends up happening is, if you were to look at that original code, we could actually do this as a team together. I suppose it's lab 3. And oh, there it is. When I was first doing this problem, I did not do it in this really highly documented thing. The first thing that I did was these few lines of code, and that took me about 45 minutes. These 2 lines of code, even though it doesn't look like that, this line right here took me about 45 minutes to get everything that I wanted in the way that I wanted it. Once I had that line of code, the next thing that I did is figure out how to implement these things individually, and I did that all in a sandbox. And then the moment that I had my data imported properly and saved as the appropriate variables, then I went back to my test script and I literally just copied and pasted those solutions in. Okay, so now what I've done is I've solved the following problem. Take the CSV file, import that CSV file into Matlab, save it as a variable. Okay, in this problem, what am I being asked to do, or what I was going to ask you to do? Create graphs. So the first thing that I did next was actually I read for about 3 hours, because when I went to go test everything that I had, I realized like, oh, Matlab has new functionality. So I literally read for about 3 or 4 hours all the things that I could read on figure properties, axes properties, how that works, right? The moment after I finished reading, the thing that I did is I actually learned how to plot. So I said to myself like, okay, let me take the position and let me see if I can just plot the position. It was not in this really, really nice code. It was literally in a sandbox. I imported my data, it was in my workspace, and then I figured out how to use figure. The moment I figured out how to use figure, the next question that I had was, can I plot it? So all this stuff was done. I literally just plotted it. Then I was like, okay, now I want to control the color. Can I control the color? Can I control the width? Can I control the limits? So then I solved all that stuff, ported it back into my script file. Once I had that, I started to get really specific. I'm like, okay, now can I control all these things? Every time that I was doing those tests, I did those tests in a sandbox to make sure that my code was working. Once the code was working, I would bring it back into the original file, make sure that it integrated properly, and then move forward. And then after I had a bunch of code that worked, did well, that's where I started to partition it into different functions, each of the functions that I had definitely worked well. Then, after I had my entire script file that worked well, each of the functions working well, each of the subplots working well, then and only then, can you guess what I started to do? Document it as such. There were times when I was doing stuff that I would make a quick documentation note just so that I remembered for myself, like, oh, these are the things that I want to do, right? And there are times at which, like, I actually will write full documentation. But when you're working on code in this class, one of the things that I would encourage you to kind of try out is create a scenario in which when you're first writing your code, you're not trying to solve the entire coding problem in one go. Instead, what you do is you focus on a very, very small subset. You get a working solution to your subset. Once you're 100% sure that that working solution is in, you put it in a space where all your working code goes. Take the next piece. Find a working solution for the next piece, make sure that it's working, take it out of the sandbox, put it in your next one. The whole time that you're doing this, making sure that the script file that you design appropriately manages the different sub pieces and integrates those into an overall flow so that your program, as it executes, takes piece 1, integrates it with piece 2, integrates it with piece 3. Each time, as you build that programming structure up, you're testing to make sure that the pieces work out individually. At the end of my code, when I finished a good piece of code, I probably will have tested it 30 to 300 times. The first time I run my final package is literally probably like the 30th or 300th or 1000th time that I've run my code. So that the entire time I'm writing code, I'm actually debugging each individual piece while I'm writing that piece. There's a name for this style, and I've read it at some point in my life. I don't. Does anybody know off the top of your head what that style of coding is called? I don't. There's a name for that. There's a name for the idea that you cut up code into smaller pieces. You test each piece individually, make sure it's working. You debug that piece. You bring it back into the larger structure. Say it again. Yeah, it's definitely iterative design. There's a formal name in the computer science literature. It's useful, right? I'm going to shut up now and let you all start your labs. As you're working on your labs, I encourage you to do that. If you have questions, you can come see me. And then next week we will get into our first numerical analysis problem, which is Newton's method. All right, go at it, y'all.